Okay, let's go to the learning activity number 32, I think. Is about the length of an arc, the arc length. So we have a function and we want to measure walking through the function from point A on the curve to point B on the curve. How many meters can we walk through the curves? Okay, and there is a formula that we have derived in class, and it's the formula that we will use. So these are the 10 problems that we are going to solve, and let's go for the first one. But before, let's go to remember the formulas, the equations that we have derived in class. If I have the length, if I have a function f of x, whatever is the function, and I want to measure the small DDS, the small length that exists on the curve DDS, I will say like this: if DDS is very, very small, I will trust that Pythagoras theorem will work. So I will say this is ddx, this is ddy, and this is dds. So there is a triangle. So dds, ddx, and ddy. So I would say Pythagoras theorem will work. Pythagoras theorem will work. Ddy. Ddy. Okay, let's go to put it in big. Ddy, ddx, dds, and Pythagoras theorem would say dds squared is ddx squared plus ddy squared. Ddy, let's go to put it like this, ddy squared. And let's go to put ddx squared like this. So dds is square root of ddx squared plus ddy squared. So if we divide by ddx squared and ddy squared, well, we should do it like delta x and delta y. I try to make it to shorten well, ddx. If you divide by ddy, or ddx squared, if you divide by ddx squared and you multiply by ddx squared, nothing will happen because this is 1. This is 1. Now I will put inside ddx, I will multiply and divide by ddx. So ddx squared plus ddy squared. Now if I introduce this ddx inside the radical, I have to introduce it ddx squared. So it will be ddx by the square root of ddx squared divided by ddx squared plus ddy squared divided by ddx squared. And now there is the formula for dds. It says that the formula for dds is the square root. This is 1. This is 1, and this is the derivative of y respect to the x squared. Let's go to put it. It's ddx multiplied by the square root of 1 plus ddy divided by ddx squared. So dds is the square root of 1 plus y prime of x squared by ddx. And this is the small length of the curve following y of x. It depends on the derivative of the function. Big derivative produce big DDS. So what it says is the total length between the point A and B between point x equal a and x equal b is the integral of 1 plus y prime of f of x squared. Y prime of x is squared by d dx. So this is another application of integrals to find the arc length of a curve. And another application, to remind you, another application is the surface area of a curve. So let's go to remember the surface area of a curve. So I have the curve, I have the DDS. Which DDS? Well, the DDS that I already found. And when I revolve this curve through the x-axis, I will find a figure who has volume. I will revolve through the x-axis, and I know how to use this method to find the volume. Okay, but what about the surface area? What is the equation that I have to use to find the surface area? To find the surface area, let me draw this a little bit better, nicer, so it will be something like this. Okay, something like this. So what about the surface area? Now, if you see this profile of the function and you see the surface area, imagine an onion ring. There is an onion ring here, and you are going to measure the surface, the exterior surface, or imagine a wedding ring, and you are going to measure the surface, the exterior surface of the ring. So what you will do? This is my ring. This is the wedding ring. The wedding ring have. Let's go to put it. This is the surface that I'm measuring. This is the surface of the wedding ring. The wedding ring have a radius. The radius is the function y of x. The wedding ring have the radius y of x, and the size of this length is DDS. So now I will take a scissor and I will cut my ring. When I cut my ring, I will see something like this. This will be DDS, and this will be 2 pi by y. So the area of the ring, the area of the surface, of the exterior surface of the ring, the area I will call the surface area, the DDA. The surface area, it will be 2 pi y by DDS. But because DDS is the square root of 1 plus y prime square by ddx, I have the area, I have the surface area. So the total area, A, the total surface area, A, is the surface area, will be the integral of 2 pi y of x. So it will be a function of x, a square root of 1 plus y prime of x squared. So it will be a function of x by ddx. And if I have to find the surface area of all these rings, the surface area of all these rings, 1, 2, whatever, infinity ring I will put here, between x equal a and x equal b, well, I will make the sum or the integral from x equal a to x equal b. And this is the equation that we will use to solve problem. Let's go now to solve problem. So let's go to problem number 1. It says find the distance between the point 0, 0 and the point x equal 8, y equal 15. So it say check the equation, check the formula from the arc length and test it between the points 0, 0, 0, 0 and 8, 15. Before testing the formula, this is the point 8, 15. Before testing the formula, 0, 0 and the length that join the 2 points, the length that join the point x1, y1 and x2, y2, the minimum length, the distance between 2 points, the formula for the distance is Pythagoras theorem. And Pythagoras theorem will say that the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So the picture for this graph is, this is the point x1, y1, this point. This is the point x2, y2. This is the point, and the distance is this square, which is x2 minus x1 square plus this square, which is y2 minus y1. So this is the side, and this is the other side, c. So c, the other side square, is x2 minus x1 squared plus y2 minus y1 squared. Now, what is the distance? So the distance here, Pythagoras theorem will say that the distance between these 2 points will be 8 minus 0 squared plus 15 minus 0 square root. And if you do the calculations, this will be, let me do it, it will be a square root of a squared is 64, plus 15 squared is 225, and 225 plus 64 is 289, and 289 is 17, is square root of 17 is 289. So 17 is this is 17, this is 17, this is 8, and this is 15. So let's go now to use our formula for the arc length to find the 17, the length of the between 0, 0 and 8, 15. So the first question is, who is y of x? Y of x is the rectilinear lines that goes from 0, 0 to the point 15, 8. What is the equation? What is this equation? This equation is the equation of the function y of x is the function whose slope is 15 divided by 8 x. When x is 8, y is 15. When x is 0, y is 0. Plug in numbers, and this is the function. Okay, so now let's go to use our equation, our formula for the arc length. The arc length is the integral from x equals 0 to x equals 8 of the square root of 1 plus the derivative of f respect to the x. The derivative of the function respect to the x is 15 divided by 8 square ddx. If you make this integral, you should find the 17. Well, let's go to do it. It will be the integral from x equals 0 to x equals 8 of a square root of 8 squared is 16.4, and 15 squared is 225 divided by 8 squared, 64, plus 1. 1 is 64 divided by 64 ddx. And now I can find the number that is on the radical, that is 225 plus 64, which is 289. 5 by 4 is 206 by 2 is 289, divided by 64 ddx. But the square root of 289 divided by 64, it can go out of the integral from x equals 0 to x equals 8. It can go out of the integral because it's a constant, and the integral of ddx between 8 and 0 is 8 minus 0, or 8. So if you multiply this, you should obtain the 70. If not, it's because I made a mistake. Please check it. Let's go to the next problem. So now it says find the arc length of the graph of the function y of x equal 2/3 x squared plus 1 square 3/2 raised to 3/2. I don't have to represent the function to calculate the arc length on the interval between 0 and 1. I suppose that between 0 and 1 exists a function, that is this function. Between 0 and 1 exists a function, and I'm going to calculate the arc length, the sum of all the small dds, dds by dds, or dds1 plus dds2 plus ddsn, and I divide the length in infinitesimal number of parts, and I will sum. This is the concept of an integral. And what is one element of DDS? One element of DDS is square root of 1 plus y prime square ddx. Perfect. So the s will be the integral of this. And what is y prime? Y prime of x will be 2/3, is the derivative of this function. So it will be 2/3 multiplied by 3/2. It would be 1. So let's go to write it. This 2/3 multiplied by 3/2. The derivative of this x squared plus 1 will be x squared plus 1 raised to the power 3/2 minus 1. 3/2 minus 1 is 1/2, multiplied by the derivative of x squared plus 1, which is 2x. So this will be 3/2 and 3/2 will cancel with the 2. 2/3 and 3/2 will cancel. It will be 1. And this will be equal to x squared plus 1, 1/2 multiplied by 2x squared. And what I need in the formula is y prime squared. So y prime squared would be x squared plus 1 by 4x squared. Or in other words, it will be 4x4 plus 4x squared. And now we need 1 plus y prime squared. So 1 plus y prime squared will be 1 plus 4x4 plus 4x squared. Or if we write it in the correct order, will be 4x4 plus 4x squared plus 1. Or if we write it like the square of two terms, the 2x squared will produce, when I square it, will produce 4x4. The second term will be produced if I write this like 2x squared plus 1 squared. Let's go to do it. If I put it like this, it would be a square of the first, 4x4, plus 1, plus 2 times the first by the second. 2 times the first by the second is this term, 2 by 2 is 4, 4x squared by 1, 4x squared. So this will help me because there is a square root of something. It will help me because the square root will cancel with this square. So the equation that I will have is that the DDS will be equal the square root of 1 plus y prime squared ddx equal square root 1 plus y prime is 2 x squared plus 1 squared, or 2x squared plus 1. Now this is the DDS. Now I have to find the S. The S is the integral of DDS. So the S is the integral from x equal 0 to x equal 1 of DDS of 2x squared plus 1 ddx. And this integral, sorry that the ddx was missing here, dd's is, sorry, it was missing the integral, and the integral, and the ddx from x equals 0 to x equal 1. Okay, and this integral, ds, will be 2x cubed divided by 3 plus x, evaluate between 0 and 1. For 0 is easy, for 1 is easy, so the integral will be 2 multiplied by 1/3 plus 1, which is 2/3 plus 1, which is 2/3 plus 3/3, which is 5/3. 5/3 is the length of the arc of this curve between 0 and 1. So the curve will be something like this, and between 0 and 1, if you walk through the curve, you will walk 5 divided by 3 meters, if x is in meters. Let's go to the next problem. Now this problem is more of the same. The function y of x is 2/3 x to the 3/2 plus 1. And remember that the DDS is the square root of 1 plus y prime square ddx. So let's go to find, and the s is the integral of DDS. And this is between 0 and 1, so it's the same example, the same exercise of problem 2, but with a different function. Let's go to do it. So y prime of x is 3/2 by 2/2 is x. 3/2 minus 1 is 1/2 plus 0. So y prime of x is this thing. 1 plus y prime of x is 1 plus x 1/2. No. Y prime square is x. And 1 plus y prime, everything squared, is 1 plus x. And the square root that appear here in this DDS is the square root of 1 plus y prime squared, or the square root of 1 plus x. Then the integral that they are talking me, the arc length that they are talking me, the s, is the integral of DDS, or the integral from x equals 0 to x equal 1 of DDS, but DDS is a square root of 1 plus x, and DDX, and what is the square root? What is the integral? What is the antiderivative of a square root of 1 plus x? Well, the antiderivative of this function of 1 plus x 1/2 ddx is a function whose derivative is 1 plus x 1/2, or 1 plus x 3/2. 1 plus x 3/2 is a function whose derivative is 1 plus x 1/2. So this I have to evaluate between x equals 0 and x equal 1. between x equals 0 and x equals 1. So the s, the arc length, it will be 1 plus 1, 3/2, minus 1 plus 0, 3/2. And it will be 1 plus 1, 3/2, it will be 2, 3/2, minus 1, 3/2, which is 1. It will be a square root of 8 of 2, of square root of 2 raised to the power 3 minus 1, or a square root of 8 minus 1. Let me see if I forgot something. Yes, I forgot something. What I forgot is that the antiderivative of 1 plus x 1/2 is 1 plus x 3/2, but when I make the derivative, it will be 3/2 1 plus x 1/2. So I need to put here a 2/3. And now this is the antiderivative, so it will be equal, the result will be 2/3 square root of 8 minus 1. And now the problem is solved. Now we go to solve problem 4. Let's say find the arc length of this graph is x4 divided by 8 plus 1 divided by 4x squared. And again, it's on the interval 1 and 3, between 1 and 3. And again, we have the function, whatever is the function, between 1 and 3, and we are measuring the arc length. The length when we walk from 1 to 3, when we walk through the curve from 1 to 3. And the equation is 1 plus y prime square root. This is the turning ball, and the DDS is equal this by DDX. So let's go to find. So y prime, it will be 4, 1/2, 4 divided by 8 is the derivative of yx, of y of x is 4 times x cubed, 4 1/2, plus minus, because the derivative the derivative of 1 divided by x squared is x minus 2. It will produce minus 1 divided by the derivative of x minus 2 is minus 2x minus 3. So it will be minus 2 x minus 3 with the 4 here. So y prime of x will be 1/2 x cubed minus 1/2 x cubed. Wow, what a symmetry with the x cubed. 1 plus y prime square, 1 plus y prime square will be 1 plus everything square. Everything square will be 1/2 x cubed minus 1/2 the x cubed square. If I do a little bit of algebra, let's go to do it. It will be now if we develop this square, let's go if we can put it, if we can do the same thing that we did on the last problem. So this will be 1 4 square x to the 6 plus 1 4 square 1 x to the 6 minus 2 times the first by the second. 1/2 x cubed multiplied by 1/2 x cubed. So it will be 1 plus 1/2 x to the 6 is 1/4 4 x to the 6 plus 1 4 x to the 6 minus these 2 with these 2 will cancel. These 2 will cancel. X cubed, sorry, 1, yes, x cubed divided by x cubed, it will cancel x cubed with this x cubed, so it will be minus 1. So I'm lucky because now what I have is 1 4 that multiply x to the 6 plus the 1 will cancel with the 1. The 1 will cancel with the 1, and it will be 1 4 common factor x to the 6 plus 1 divided by x to the 6. And this is 1 plus y prime squared. And the integral that we have to solve, the s will be the integral from x equal, I don't remember, x equal 1 to x equal 3 of the square root of 1 divided by 1 plus y prime, so it will be 1/2 x to the 6 plus 1 divided by x to the 6 ddx. And how I will do this integral? Wow. Use trapezoidal rule and do the integral and do what? And approximate the area to use trapezoidal rule. Okay, and let's go to the next problem. The next problem is say find the arc length of the function y equal 1/2 e to the x plus e to the minus x over the interval 0 and 2. And this function is defined, is named, the sum of this function is named as cosine hyperbolic of x. The cosine hyperbolic of x is defined like e to the x plus e to the minus x divided by 2. Or in other words, the cosine hyperbolic of x is, this is the one, e to the x will do like this. E to the minus x will do like this. And cosine hyperbolic of x is at the point x, cosine hyperbolic of x takes the height of e to the minus x. The height of e to the x, they sum it and they divide by 2. So the sum will be something like this plus this is this, divided by 2, so it will be around here. So if I do it here, I might take the point x, that is negative, the sum will be this plus all this. So it will be all this plus this, the sum divided by 2 will be something divided by 2, this is everything, sorry. This is everything, and divided by 2 will be here, so the graph of cosine hyperbolic of x should be something like this. Let's go to draw in yellow. But because at the point 0, e to the 0 is 1. E to the minus 0 is 1. 1 plus 1 is 2. 2 divided by 2 is 1. So this is cosine hyperbolic of 1. And cosine hyperbolic of 1, it looks like the shape of the cables that are hanging up in the electrical towers. The electrical towers, they have cables that hanging up like this. And the graph of this function is hyperbolic cosine of x. Of course, it's similar like hyperbolic cosine. Okay, I mean, if you take the system of reference like this, the cosine hyperbolic is something like this, right? Is something like this. So it would be cosine hyperbolic minus something. Okay, but we'll see later. Now let's go to solve the problem. Well, again, the same procedure. 1 plus y prime square and the square root, and this, I will make the integral of this, Okay, so y prime, y of x is 1/2 e to the x plus e minus x. Y prime of x, it would be 1/2 e to the x minus e to the minus x. And you know which function is this? It's called sine hyperbolic of x. This function is the sine hyperbolic of x. So what we have discovered is that the derivative of x of cosine hyperbolic of x, where cosine hyperbolic of x is e to the x plus e to the minus x divided by 2, is equal to what? To sine hyperbolic of x. Well, but this is not the problem. The problem is to find y prime, to find y prime square, to add it 1, and to make the integral. So it will be 1 plus 1/4 e to the x minus e to the minus x. This is y prime square. So it will be, so I have squared the 1/2 and convert it into 1/4. So it would be 1 plus 1/4. It will be the square of the first, e to the x square, e to the 2x, plus the square of the second, e to the minus x square, e minus 2x, minus 2 times the first by the second. The first is e to the x multiplied by e to the minus x. And e to the x multiplied by e to the minus x is e to the 0, which is 1. So it would be equal 1 plus 1/4 e to the 2x plus e to the minus 2x minus 2. So 1 with minus 2 is, 1 plus 1/4 of 2 is minus 1. It would be cancelled. So it will be 1 plus, it would be the 1 will cancel. It would be 1/4 e to the 2x plus e to the minus 2x. And now I have the 1 here, and I have the minus 1/2. 1 minus 1/2 is plus 1/2. Oh, wow. Let me do it again. So it will be 1/2 that multiply 1/2 e to the 2x plus e to the minus 2x plus 1. Now it will be, now I found it, 1/2 of 1/2. What is e to the 2x plus e to the 2 minus 2x plus 1? This is e to the 2x plus e to the minus 2x square. I found it. See, Yes, this is the square. So now I'm just focusing of telling a square because I know that the formula for the arc length is with the square root. So the formula will be, the s will be the integral of the square root of 1 plus y prime square ddx. Now it will be this integral of 1/4 will be out, and this is 1 plus y prime square. Let me check. Yeah, this is 1 plus 1 prime square, so it will be the square root of this. So this will produce 1/2. 1/2 of the square root of e to the 2x plus e to the minus 2x is square. And now will be 1/2 the integral from x equal, let me see, from x equal 0 to 2, 0 to 2, from x equal 0 to x equal 2, or e to the 2x plus e to the minus 2x, because the square and the square root and the square will cancel. ddx. Okay, so it will be 1/2 the integral of e to the 2x is e to the 2x. Now if I make the derivative, it will be a 2, so the integral is 1/2 e to the 2x. So the integral is, now the integral of e to the integral of e is of e minus 2x is e minus 2x, but if I make the derivative of this, it will appear a minus 2, so I will divide by minus 1/2. And now I think this is the integral. It will be 1/4 e to the 2x minus e to the minus 2x, evaluate between 0 and 2. So it will be 1/4, wow, 1/4 e to the 4 minus e to the minus 4. Open parenthesis here, 1/4, this evaluation minus evaluate at the point x equals 0. E to the 0 minus e to the 0. E to the 0 is 1. 1 minus 1 is 0. So it will be, this term will be 0. So at the end it will be 1/4 e to the 4 minus 1 divided by e to the 4. Well, and this is the length. The length should be bigger than 2, because the graph, is in between 0 and 2. According to the graph between 0 and 2, 1, 2, this length is 2, but because the graph of the function is this graph, this will be bigger than 2. Bigger than 2, of course, you know. Bigger, this distance is smaller than the distance that is here. This distance, the yellow distance, the path that you walk through the curve will be bigger than the 2. Let's go to check, maybe. Let's go to check if it's bigger than 2. So we are sure that we did it right. So it will be 1/4, 2.7 to the 4 minus 1 divided by 2.7 to the 4. 2.7 to the 4 is a small quantity. And 2.7 raised to the 4 is like 3, this is bigger than 2. Wow, but this is too big. It's too big. It means that the slope is too high. Yeah, could be so high the slope between 0 and 2. Maybe I did a mistake. You check it. You check it. I'm sorry that I have. It's too late. Let me go to the next problem. Set up the integral of the arc length of the graph of the function y equals sine of x over the integral 0 and pi. So sine of x, you know what is the function, is the function who is 0 at x equals 0. It takes the value 1 at pi divided by 2. It takes the value 0 at x equal pi. So it's this function. And what it say is set up over the use a graphic utility to approximate the integral. It means that you will not be able to do the integral with the technique that we know. So the integral will be 1 plus y prime squared, or 1 plus the derivative respect to the x of sine of x, and once that I find the derivative, I will square it, or 1 plus cosine of x, the derivative of sine is cosine, everything squared, or 1 plus cosine squared of x. And 1 plus cosine squared of x, you don't know what formula is. You know the formula for cosine squared of x minus 1, which is sine squared. But you don't know this formula. So the arc length will be the integral from x equals 0 to pi of the square root of 1 plus y prime, of 1 plus y prime square of 1 plus cosine square of x dx. So you plug in numbers in your calculator, you have a graphic utility that can do the integral, and you approximate this integral. For sure, this integral has to be bigger than pi. Pi is 3.14. So this integral maybe is 4.5, 5 meters. So you have pi meters here, 3.14, and you walk through here. How many meters you would walk? This is the result. How many meters? I guess it could be 5. But do with your calculator and you let me know, please. Problem 7 say, set up and evaluate the definite integral for the area surface generated by revolving the function y equal x divided by 2 in the interval x equals 0 to 6. So y the x divided by 2 is the function whose slope is 1/2. At the point 6, at x equals 6, the value of the function is 3, 6 divided by 2. So this is the point 6,3. And this is the function. And it says by revolving through the x-axis. If you revolve the graph through the x-axis, you will find a cone. Oh, a cone. And now what it says, find the surface area of the cone. So I will find the surface of this element, of this ring. And as you remember at the beginning of the video, I said that the area, the surface area, DDA, the small area that is here on the ring is 2 pi y of x, 2 pi the radius, which is y of x. So I have done this area. The area of the ring is 2 pi f of x, and the ring have the size here dds by dds. And dds, we know what it is. dd area, the area is 2 pi y of x by the square root of 1 plus y prime of x square dx. And this is the small area that we consider, so I have to find the total area. The total area, let's go to call it A or S, better the S, the total area S, it will be the integral from x equals 0 to x equals 6. So it's the area of the surface of the cone, not taking into account the area of the base, the pi by 3 square. Not taking into account only the lateral surface of the cone. Okay, it's 2 pi, it's a nice problem. Y of x is x divided by 2. And the square root of 1 plus y prime is square. Y prime is, because y of x is x divided by 2, y prime is 1/2. 1/2 square by d dx. So this integral is easy to find. So the area S will be 2 pi go out, or pi go out, the 2 with these 2 will cancel here. So it will be pi by the integral of x, so the square root will go out, let me erase here, pi, it will be 1 plus 1, 4. So it will be 4, 4 plus 1, 4, which is 5, 4. So 5, 4 of the integral of x by d dx between x equals 0 and x equals 6. Sorry, 5, 4, square root of 5, 4. Square root of 5, 4. So it will be pi by the square root of 5, 4. The integral is x squared divided by 2. And we evaluate between 6 and 0. 0 is fast, is easy to evaluate. It will be pi square root of 5 divided by 4 multiplied by 6 squared divided by 2 minus 0. Okay, so the area will be pi square root of 5 divided by 2 multiplied by 36 divided by 2, which is 18. 18 divided by 2 is 9, so it's 9 pi square root of 5. This is the area. Okay, the problem is done. Remember, this is the surface area of the cone. Will you be able to do a general formula for the surface of a cone like this? What I mean, given the height of the cone is 6 in this case, will you be able to do a general formula for a cone of radius r? The surface of a cone of radius r and height h. Oh, can you do it? Using this formula? I may ask you in a quiz or in a test. Can you try to do it? It's exactly the same thing that we have done. Only you integrate from x equals 0 to x equal h. And the radius r, this radius r, it will appear where it will appear. The radius r, it will appear in the function y of x. Y of x will be the equation of a rectilinear line. This y of x will be the equation of a rectilinear line that pass through the point x, r. And the equation of the line that pass through the point x equal r, it will be r divided by h, which is the slope by x. This is the slope, and this is the graph, the function. The function is y equal mx. Mx, when m is a slope that is r divided by h. So now the problem is, given the function y equal r divided by h by x, can I find a formula for the surface area? So what I will do, I will plug in the y of x here, r divided by h x, and I will find the small area, 2 pi r divided by h x, square root of 1 plus y prime, I will find y prime. Find a general formula for the surface of a cone. I challenge you that you can find. Send me a video with this formula. Okay, good luck. Now we solve problem 8. Problem say, set up and evaluate the definite integral for the area surface regenerated by revolving the function y about the x-axis between minus 1 and 1. Between minus 1 and 1, the function is well defined. For example, for 0 is the square root of 4. For 1/2 plus 1/2 is 4 minus 1/2 squared, which is, this is a positive number. And from minus 1/2, this is a positive number, so the square root exists. What happens if you go out of this interval? If you go to the number 2, well, 2 squared will be 8, 4 minus 8 will be a negative number, and the square root will be not be defined. So this function is well defined between minus 1 and 1. And what is the graph of the function? Well, the graph of the function should be something like this, between 1 and minus 1, when it's 0, the graph is a square root of 4, which is 2. And when it's 1, the graph is a square root of 3. A square root of 3 is like 1.7, so it will be like this. And when it's minus 1 is a square root of 3, the value. So the graph will do something like this. And when it's 2, is 0. And when it's minus 2 is 0. So it maybe do something like this graph, but we can use GeoGebra and graph this graph. Well, the other thing is to remember that the equation of a circle is x squared plus y squared equal r squared. So y squared is r squared minus x squared. So y is plus minus a square root of r squared minus x squared. So the equation that the problem is presenting is plus a square root of 4, which is 2 squared minus x squared. So this equation corresponds to the top part of the circle. So if this is a circle, okay. Indeed, this is 2, and this is also 2. So the radius and the radius is 2, so sorry about my picture, it's a complete circle. So it's a complete circle, but the upper part of the, so the radius is 2, 2, 2. Okay, and what it's asking me is, if you revolve this circle through the x-axis, you will find a surface, and the surface will be the surface of what object? It will be the surface of a sphere, and the surface of a sphere is 4 pi r squared. So the surface of this problem should be 4 pi, because r is the 2 square. So the surface should be 16 pi. Let's go to calculate the surface of a sphere. Wow, we can do it. What is the equation that we have? The equation that we have is that the surface of a sphere is 2 pi y of x. 2 pi y of x is the radius. Remember my picture. This is the function. This is the y of x. So I will do I will do the radius, the 2 pi x, the length of the circumference by dds, and I will sum. So this is the small area. The small area, so this S and this S is a different S. This is area, this is length. So I may call it the surface area, surface area. So let's go to plug-in numbers to see if this will work. The surface area, the small surface area that will exist here, when I revolve through the x-axis, this will be a sphere. The surface area, I will calculate a ring, my wedding ring. My wedding ring. You see my wedding ring? You see my wedding ring? I will calculate the area of my ring, of my tiny infinitesimal ring. It will be 2 pi. Y is the square root of 4 minus x squared, and dds is the element of dds here, the dds, the arc length is, wow. Let's go to put here dds, the arc length, and let's go to calculate the dds here, the small arc of length. The small arc of length dds, it will be the square root of 1 plus y prime squared ddx. It will be the square root of 1 plus y prime, y of x, is the square root of 4 minus x squared. Or in other words, is 4 minus x squared 1/2. So y prime of x is 1/2 4 minus x squared minus 1/2 minus 2x by the derivative of 4 minus x squared, which is minus 2x. So the 2 will cancel with the 2. So y prime of x will be minus x divided by 4 minus x squared square root. So y prime of x squared will be x squared divided by 4 minus x squared. And the term that appears in the arc length is 1 plus y prime squared. So it would be 1 plus x squared plus 4 minus x squared. Or 4 minus x squared plus x squared divided by 4 minus x squared. Or 4 divided by 4 minus x squared. And the term that appears in the arc length is the square root of 1 plus y prime squared ddx. Or in other words, a square root of 4 divided by 4 minus x squared ddx. And the area, the surface area, S, the capital S, don't confuse the surface area with the arc length. The surface area is 2 pi by y of x by dds, by the small dds, the arc length. Okay, this S is different than this S. So the surface area will be 2 pi. Y of x is the square root of 4 minus x squared. And dds is a square root of 4 divided by a square root of 4 divided by the square root of 4 minus x squared ddx. And now I I can see that this will cancel with this. So the surface area between -1 and 1 is the integral of this. So sorry, I didn't do the integral from x equal -1 to x equal 1. So it's 2 pi by the integral from x equal -1 to x equal 1 of d dx. So the surface will be 2 pi by square root of 4, which is 2, by the integral from -1 to 1 of d dx. And the integral from -1 to 1 is 2. So it would be 4 pi by 2, or in other words, would be 8 pi. Wow. And the problem is solved. Now your challenge is, it will be like this. If I have the equation of the circle, if I have the equation of the circle, y of x equal plus square root of r squared minus x squared. This is the r. This is r, this is minus r. This is x equal minus r. Can I revolve through the x-axis and find the surface area of the sphere that will be generated by revolving the function y equal x, y of x equal square root of r squared minus x squared? In other words, will I be able to find the surface area S like the integral of the small surface area? Let's go to put it. The small surface area. The small surface area. Like this, we revolve, we have the sphere, we put our ring, wedding ring, we found the surface area, and the surface area will be 2 pi f of x, 2 pi the radius, which is f of x, 2 pi f of x, it means this function, f of x, 2 pi f of x by d ds. This is the small area. Can I find a general formula to prove that the area S, when I integrate this expression from minus r to r, can I find 4 pi r squared? This is your challenge, to prove that the surface area of a sphere is 4 pi r squared in a general formula. You can do it. Okay, let's go to the next problem. Next problem says, set up and evaluate the definite integral of the area of the surface generated by revolving y equal 9 minus x squared between 0 and 3 about the y-axis. If I revolve through the x-axis the graph 9 minus x squared, when x is 3 is 0, when x is 0 is 9, and is a part of a parabola, and it will do like this. If I revolve through the y-axis, I will perform not exactly, I perform something like this, and this is minus 3. I will perform, if I rotate this graph through, I will perform, and they ask me about the surface area. So I need to find my wedding ring here. And my wedding ring will be this one. Now the orientation of my wedding ring is different. Before, the wedding ring was like this one. This was my wedding ring, and I was finding the surface area that is here is on the surface area, the surface that is the area that is on the surface. Now the ring is different. I believe we have to use another formula, a different formula. So the ring will go around here, okay, around here. I don't want to go is like this, you imagine the other revolving. So the formula for the arc length now the radius will be x of y. Oh, the radius will be x of y. So the surface area DDA, let's go to put surface area DDA, area, surface area. The surface area, not to confuse to the element DDS, the surface area will be 2 pi by the radius 2 pi y, now 2 pi x of y, 2 pi by the radius by the element DDS. DDS. So this is the formula. Now in this case, when you rotate through the y-axis, but there is a detail I think here. DDS square is ddx squared plus ddy squared. When we found the element of the arc length, this is the arc length. Now you remember the trick. We divide by ddx. Now we are going to do it in the opposite way. Instead of dividing by ddx, we are going to divide by ddy. ddx square divide plus ddy square divide by ddy square, and let's go to do it well. So ddy, so I will multiply by ddy square divide by ddy square. So this is dds square. So dds square will be ddx square plus ddy square divide by ddy square divide by ddy square and multiply by ddy square. So dds square will be ddx divided by ddy square plus 1 multiplied by ddy square. So dds will be the square root of the derivative of x respect to the y square plus 1 multiplied by ddy. And now I have to use the formula with this dds because I have x of y. Okay. So what is the formula for the surface area? Is here. This is the element of the area. 2 pi x of y. But I have the y that I have is y of x is 9 minus x squared. This means that x squared is 9 minus y. So x of y is a square root of 9 minus y. So let's go to plug in here. Remember this equation. I'm going to write this equation like this. At the end, let me write it here. 2 pi x of y by dds. So the element of area is 2 pi x of y by the element of arc length, dds. Or in other words, 2 pi x of y is square root of 9 minus y by dds. Wow! But the element dds, I need to use this formula. Wow! So let's go to find the x of y. We know, let's go to find x of y. We said that is equal to x of y is equal to square root of 9 minus y, right? Plus square root of 9 minus y because it's plus the square root of 9 minus y. X of y is the square root of 9 minus y. So I'm trying to find the arc length. The arc length, the element of arc length is the square root, so I need to find the derivative of x respect to y. So this is the derivative respect to the y of 9 minus y 1/2. So it will be 1/2 9 minus y minus 1/2 minus 1. So it will be minus 1/2 9 minus y minus 1/2. So the term that I have to find is the derivative of x respect to the y squared plus 1. Okay, wow, big work, eh? Big work. Let's go to do it. So the derivative of x respect to the y is squared plus 1. This is 1/4 9 minus y minus 1/4 plus 1. Oh, why? This is too long. Well, because it's too long, I'm going to leave you for you to do it. So please do this problem and do the following one because I'm tired. I think you can do it. Okay, good luck.